All right, good afternoon. Since it's Friday, we're going to spend today talking about the lab that you are in the process of doing. I apologize, a few people came to office hours with questions about the contents of most of these slides. The slides that are available, that you can download from the course calendar, are from last year. So by the time I show them, they may change a little bit, and that's bound to happen. So it's a trade-off. I like to leave them up there because you might get something out of them, but don't focus too heavily on slides that you download before the corresponding lecture, okay, because things will change. Okay. First, as I mentioned before, Mr. Fogel and Douglas North, who's not part of this project at all, got the Nobel Prize in 1992, I believe, for having renewed research in economic history by applying economic theory and quantitative methods in order to explain economic and institutional change. Right? So that before that, while they're not saying that they got it for Time on the Cross, the popularity of this book, the incredible splash that it made in 1974, convinces me that they would have gotten it without that, but that is somewhat speculative. These aren't really the main points of the lecture. These are really the main points of the last lecture we talked about. Right? Slavery's growth and expansion into the New South is a big surprise to 18th century thinkers. And when I'm talking about 18th century thinkers, we're talking about the framers of the Constitution, the Revolutionary generation, who didn't do as much, I should say, who allowed slavery to continue, at least in part, because they didn't think it had much of a future. Second question we also talked about last time, that is the central issue of the lab today, and a side issue of Fogel and Ingerman's book, that is whether slaves migrated with plantations or as individuals traded in a market. It has important implications today. We won't actually talk much about those. The real main point of the lecture today is one that's not up there, which is how are you supposed to do the lab? Okay, so again, what this means is that I wave my hands over the 18th century view and migration, and instead we'll talk about estimating migration using survival rates. Okay, that's the main point. And this is described in the lab handout, but there's a lot of notation in there, and notation is complicated. The ideas are not, calculations are not, but the notation is. So it's worth going over in class to make sure that you get it. Also, I think it's worthwhile, before we start, to make a point that this is the kind of thing demographers do. I hope that when we're done, you'll see this is kind of a certain amount of cleverness in here, that we've taken data that was collected for a different purpose, we've repurposed it to find something that the census wasn't paying attention to, which was the migration of slaves. We're going to get an estimate from it. We're going to actually be able to say something about the past, which is nice. It's not to say that other social sciences don't do clever things, but this is the kind of thing that demographers do. So if you really hate it, then you know that you don't want to take any more demography classes. Okay. All right, so I'm going to wave my hands here. We've seen this before, right? The 18th century view was that slavery was moribund. It wasn't going anywhere because it just was only suitable for a few crops. The demography, high fertility, was going to doom its efficiency. And it basically only continued because it already existed. Right? Cotton gin, as we learned last time, changed all that. And after the cotton gin, huge migrations of slaves from the New South into the Old South. All right, so here's where we'll really start. Page 48 of Time on the Cross, in chapter 2, within your reading, is this, I think it's a whole sentence. Available evidence suggests that about 84% of the slaves engaged in the westward movement migrated with their owners. Right? That's the clear statement of what Fogel and Ingerman think. And one can, I think, ponder whether 16% of slaves who didn't, even by Fogel and Ingerman's estimate, is significant or not. Right? Again, it's not 100%, right? They could claim that 100% of slaves moved as plantation units, then we could say that, again, with a little bit of hand-waving, that perhaps there was very little damage, if any, to slave kinship. 16% apparently did not. So that's a question I raise. I don't have an answer for it, but I think it's worth pondering. The reason the quote is here, though, is the 84%. This is the number that we're going to take a look at. First, we're going to see how Fogel and Ingerman calculate that, and then I'm going to show you how we will calculate an array of numbers that can answer that question, or can be compared to that. Other questions? I'm hoping you have some questions today, because you're actually engaged in this lab, right? You're actually doing it. This is one of the lectures that matters maybe more than the others, because you actually have to do this stuff, right? So, right. All right, I'm sure that many of you stayed awake thinking hard about equation 2.20. This was in the technical appendix. All of Fogel and Ingerman's calculations are relegated to the technical appendix, which is downloadable, which I also put up on the website. And I think I asked you to read it, but I'm sure that if you did, you went right to sleep. This is the basis of the 84% number. And as I promised, the notation is a little intimidating, but really it's not a hard problem at all. And I have a picture to show you in a second that will make it even clearer. So first we have to decipher the symbols. Sigma bar is the total share of males in interstate migration. Right? That is the percentage of males who migrated, as male slaves who migrated. It's the percentage of slaves who migrated who are male. Right? Migration is determined here as just crossing state boundaries, from going from the Old South to the New South. Delta S is the share of males in interstate sales. Right? Okay, so that's again percentage of interstate sales. These are the ones who don't travel as plantations, who are male, and sigma M, the male share in the interstate movement of whole plantations. Right? So there are only two ways that slaves can move from the Old South to the New South. Right? They can move as sales in a market, or they can move as whole plantations. And as a consequence, the result, the share of both of those streams, that is male, is simply a weighted average of each stream. Well, let me make that clear. We'll come back to this in a second. But here's how it works. All right? Suppose instead of slaves, we're talking about blue and red dots. And suppose we're talking about this, I guess, is let's make this one the interstate sales of blue and red dots, and this the migration of plantations of blue and red dots, if you will. You don't actually need any of the story at all, right? We just have a collection of blue and red dots, two collections of blue and red dots, and we're going to put them together. That should be an equal sign, right? So we can think of one of these as these two migration streams. It's really this simple. Right? In this case, the sigma S, which is analogous to the male share of slaves in the interstate sales. In this case, it's 3/4. Where did I get 3/4? I counted 3, and then I counted the whole thing. 3/4 of the dots are blue. That means that's analogous to 3/4 of the slaves within the interstate sales are male. Right? Similar calculation for travel. for travelers plantations, 2/8. Okay, so we got 3/4, 2/8. Gamma in here is simply how big this is relative to the whole flow. So in this case, it's 4 divided by 12 because there are 12 dots in all. Everybody see that? Right. 1 minus gamma is 8/12, which is also 8 dots over all of the dots. Simple. We do this nifty arithmetic. This middle school arithmetic. Apologize for the upside down question mark. This is a failure of my understanding how to use the equation editor in PowerPoint. But you can see the result. If you add up all the dots, you can simply put all the dots in this box and count them up, and you get that answer, 5/12. Same answer as you get. You apply Vogel-Langermann's equation 2.20. All right, any questions about that? We get it? You see what they did? All right. Let's look again at it. It's an equation with a bunch of unknowns. But what I want to say, what I want you to take away from the picture with the box is that, whoops, if you knew all the unknowns, if you could put numbers on all of these gammas and deltas, it would add up. It would make sense. This is just arithmetic. This equation cannot be wrong. I think it's an identity essentially. All right. So what they do with that now is they go and find numbers for each of the missing pieces, and they have delta bar. That, let's look back, is the total share of males in interstate migration. Right. That's the number of males divided by the total number of migrants, of slave migrants. They get that from somebody else, from Claudia Goldin, and they plug it in. So they're claiming that 0.51, in other words, slightly more than half, but not much, of the interstate migration of slaves is male. It's just very slightly more male than female. The assumption, sigma sub m, that is the male share of the interstate movement of whole plantations. Right? They're assuming that that's 0.5. Why? Yes. Right. Yeah. And so on any plantation, half male, half female. So you pick up a whole plantation, you're getting half male, half female. Very good. Okay. So far so good. Now what's left is a delta S. If you know gamma, if you know delta bar and you know delta m, and you can find a delta S, then the only thing left to solve for is gamma, and that's the number that we want to know. Right? All right. So here are 3 of them, and the 0.57 comes from their own stuff, the New Orleans invoices. So they collected data from the New Orleans slave market, and they categorized slaves as male and female, and they simply got this number, 0.57. 57% of slaves sold in the New Orleans slave market were male. Right. There are other places that they could have gone. They had, I guess, coastwise manifests to New Orleans is another source of data, and also coastwise manifests to Mobile. Mobile would have been a smaller slave market, but nonetheless, there are other choices. This is, oh yeah, that's right. Okay, so 0.6. There we go. There are the answers. So this is the range of numbers that they find from all the data sources that they have. This is their favorite one, the one that they collected themselves from New Orleans. Okay, so if you plug in these numbers, the 0.57, for example, you plug in the 0.51, the 0.511, the 0.5, and the 0.57, those 3 numbers, into equation 2 like that, you can solve for gamma. Is that? I mean, everybody, we can nod our head that. Very straightforward. Okay, that's just what they do, and they get numbers like that, which are 1 minus 84. Right? Okay, this is essentially 0.16. This is 1 minus that, 0.84. 84 is the number that we saw on page 48. That's the answer. Right. So, 2 things to note about this. One, the obvious thing, it's based on an assumption, a number that somebody else got, and a number that they cooked up from the New Orleans invoices. Right? There's nothing wrong with that, but we're going to do it using the entire census data. So I think our information is a little bit better. We are actually going, the method I will show you, that I think many of you already have a pretty clear idea of, is in some sense more robust. It's pretty clear there could be errors, right? I mean, they collected data from a slave market. Not every slave who was traded on the market went through New Orleans. Perhaps a lot of them did. They claim a lot of them did, but we certainly know that not all of them did. There's some chance that there's a systematic bias there. Perhaps there is, perhaps there's not. We don't know. I just want to put it out there that our data, since it's complete enumeration, I think is perhaps a better source. The second point I think is more subtle, and it follows really from the numbers that they actually use, and it's this, that if you use equation 2.20 and you use those numbers, those 0.511 and the 0.5, then gamma, your calculation of gamma, is really quite sensitive to small changes. I mean, this is just an arithmetic fact from the choice of numbers they use. I'm not dissing equation 2.20 is right. It's got to be true. But things are imperfectly measured, and when we look at, if we plot gamma against various values of delta S, you see that once you get close in towards 0.5 for delta S, gamma shoots very high. If you go past 0.5, it even goes negative, which is an absurd answer. Right? Okay, so it's much points, right? It's a fine equation, except that it's based on a sample, slave market sample. Its representativeness is not something that we can be 100% confident of, and at least in the range a little bit less than what they got. Here are the numbers that they actually plugged in. If you plug in numbers, if they happen to have found a delta S from their data that was closer to 0.5, well, things would have blown up. So these, I think, are good reasons for trying to find the answer another way. Which brings us to the lab. In a nutshell, here's how you do it. Get the data. You calculate an estimate of the number of migrants at each age and sex, and that's what I'm about to show you how to do. Then you make some graphs. Then you form a thesis. Then you make some graphs. Then you refine your thesis. Then you make some graphs. Okay. And when you're done, you write 272 words. Again, this part you do with your group. This part you do by yourself. 272 words are your own. Right? Okay, questions so far? Okay, then let's get to the point. I think you've all seen the data by now, but to remind you, this is what we have to work with. We have states, and we have counts of slaves at different ages. And this is a little bit chopped off. It's 850 slaves male, slaves female under 1. That's female slaves in 1850 who are aged less than 1 in each of these states. Yes? The numbers in row A? I don't know. Pay no attention to the numbers in row A. Yeah, you don't need them. Row B is a data type, and that means state. There's also county level data in this file. Someplace I don't think I gave it to you, but it's there. 850 is short for 1850. And ICPSR state codes are not needed, but they correspond to just a number that corresponds to the state. All right, there are two files, one for 1850, one for 1860. It's actually pretty straightforward. Okay, so what are we going to do with that? Well, we're going to start, as all demographers do, with the fundamental equation. This is the fundamental equation of population, and it is, I think, fairly obviously true. Population in time t is equal to the population in time t minus 1, last year, yesterday, 10 years ago, plus births that have occurred since t minus 1, minus deaths that have occurred since t minus 1, plus immigration, minus immigration. Right? So what else can there be? Right? We've got births, we've got deaths, we've got in-migrants, we've got out-migrants. Visitation from other planets, we rule out. What else? It's pretty exhaustive, right? Okay, so luckily we can actually do something with it. If we look here at this picture of the United States, we can consider 1/2 of the United States. Let's think for a moment about the New South. Now, because the slave trade, the international slave trade, was banned in 1808, and even more importantly, the international slave trade was banned by Britain in 1808. That's a little more important because the British are in charge of the Atlantic Ocean, we say, and for the British, trade in slaves after 1808 was piracy, and they were quite willing to institute capital punishment for pirates. So there were a lot of disincentives for engaging in international slave trade after 1808. Surely there was some anyway, but we're equally sure that it was pretty small, so we're going to ignore it. If we ignore the international slave trade, then we can draw this red line around the United States as of 1860, and any immigration that occurs here has to come from there. Right? Another way of saying this is that if we ignore the blue line, we can think of the population inside the red dotted line, the population of slaves, as being affected only by birth and death. And since we know the number of births, we can calculate the number of deaths with just the population totals from the census. So how do we do that? Whoops, did I push the wrong button? I did. Okay. Let's go. All right. So first, the mortality rate. If the population in the U.S. in time t is simply the population in time t minus 1 plus births minus deaths, there must be some more to this. Okay. We can think of t as decades. Right. So the time periods are 1860 and 1850. We can limit our attention to people over the age of 10. So that is, we only look at people who were already born in 1850. Then we can back out d in this equation. Okay? And it's simply the population time t in the U.S., as population of slaves in the U.S., over the age of 10 is equal to the total population in 1850, including people under 10. I mean, yeah, the entire population, right? Minus deaths. So to find deaths, this we observe and that we observe, and we can simply subtract the population t minus 1 from the population time t, which is deaths. Right? Is that straightforward? Did we get that? All right, and then a death rate is the number of deaths minus the population. Sorry, I said that wrong. It's the number of deaths in t minus 1 divided by the population in t minus 1. And what we'll use in the lab are survival rates, which are 1 minus mortality rates. Good. Okay, is this clear? Is this too easy? Right. Good. All right, it's too clever. All this stuff. Let's put this on in here. All right. So how do we get migration then, once we have the survival rates? That's the trick. That's the main trick for the lab today. And here it is. We go back first to our fundamental equation, where we have population on one side plus last period's equal to last period's population minus deaths plus the immigration minus the emigration. Right? By assuming that mortality doesn't vary between the new and the old South, right? Assuming it's the same, then we have one set of mortality rates that we can use. We can apply it to a new South population or an old South population, to a state, whatever. That's a nice assumption, so we're going to make it. There are some exceptions. Louisiana probably had somewhat higher mortality because they have a sugar agriculture going on there. But for the most part, we think this is fairly true, that the mortality is roughly the same in the new and the old South, and we observe that both populations are